Hi students, I am going to start exercise 6.3 introduction. Exercise 6.3 introduction. Vector triple product. Vector triple product. Okay. For a given set of three vectors, A vector and B vector and C vector. The three vector A vector cross B vector cross C. A vector cross B vector cross C. Okay, so now is called a vector triple product. Okay, already I am seeing now the triple product of A vector, B vector cross C vector. So in this triple product of vector A vector cross B vector cross C vector. Okay, so now theorem 6.7 is a properties of the theorem. So the vector triple product satisfies the following properties. Okay, so first one, a1 vector plus a2 vector cross b cross c equal to a1 cross b cross c. A1 vector cross b vector cross c vector plus a2 vector cross b vector cross c vector. So a2 vector cross b vector cross c vector. Now the next one, lambda a vector. Lambda is a constant term. So lambda is a constant term. So a vector cross b vector cross c vector equal to lambda into a vector cross b cross c. Okay, so lambda belongs to real numbers. The second one, a vector cross bracket of b1 plus b2 cross c. Okay, so b1 vector plus b2 vector cross c vector equal to a cross b1 cross c plus a cross b2 cross c. Okay, so now a cross lambda b, lambda means is a constant term, and lambda b cross c equal to lambda into a cross a vector cross b vector cross c vector. Lambda belongs to R. And the third one, a vector cross b vector cross c1 vector plus c2 vector equal to a vector cross b cross c1 and a vector cross b vector cross c2 vector. Okay, then a vector cross b cross lambda c is equal to lambda into a cross b cross c vector. Lambda belongs to R. Now the vector triple product expansion. The expansion for any three vectors a vector, comma b vector and c vector, we have a vector cross b vector cross c vector equal to a vector dot c vector into b minus a vector dot b vector into c. So a cross b cross c equal to a dot c into b minus a dot b into c. Okay. Next one property, Jacobi's identity. For any three vectors a vector, comma b vector, comma c vector, we have a vector cross b cross c plus b vector cross c vector cross a vector plus c vector cross a vector plus b vector equal to 0. In this formula, equal to 0 is a Jacobi identity. Lagrange's identity. The Lagrange's identity for any four vectors a vector, comma b vector, comma c vector and d vector, we have a cross b, a vector cross b vector dot c vector cross d vector equal to a dot c, a dot d, b dot c, b dot d. Okay, so now the multiple value of A vector dot c vector and A vector dot d vector, B vector dot c vector, B vector dot d vector. Okay, so in this formula is Lagrange's identity. That's all. We will meet the next class.